is the thermal resources of sea supporting heating and cooling for the coastal area. And for the configuration of system, I will first do a SketchUp of the 3D models and then activate it, and then input all the locations, input the location in Hong Kong and then the temperature, and then I'll start to do the system component simulation, and then before that I will add the infiltration rate, ventilation, internal gains, and then the heating and cooling system, as well as the operating schedule for daily and weekly, and then following the guidelines that the PhD student provide to us, and then I will use different premises like offices, hotels, retail shop, and education activities like school to set up the buildings, and then I will add the output such as AHU heating and cooling for the heating and cooling system. And then the main components that I've used is listed below, but I didn't do a screenshot of what I've done so far, so I will just list what component I've used, and then which is mainly the air-cooled chiller and air-to-air heat pump, water-cooled chiller and water-to-air heat pump. And then for the equations, is mainly for the heat equation, which is mass flow rate, and then by dividing the cooling load, the cooling load divided by the specific heat capacity and the temperature difference, which is divided by the weather data. And then as shown in the tutorial, and then I will add the not one for the denominator, because it's better for the calculation when the system is off. And then for the control strategies, I've listed 3 of them. The first one, I will figure out the on-off system when the system is greater than 0, which is on, and then smaller and is off. And then I will try to merge the water side and air side pump system together, and then by increasing the size of the air ductwork and then the air handler, and then it can allow a larger flow control for each AHU. And then I will try to adjust the system schedule to see what's the difference between a longer period of time for the system and a shorter period of time.
So for your work, how much have you done for the simulation? Do you have a schematic for your system?
Yeah, but I haven't input the data in it. Like I've tried to use all the components and then like to fix how it works.
Have you drawn any schematics as similar as what other students did? So for the to show the interaction between different components. So what will be the energy flows? What will be the, for example, these fluid flows? Have you done this kind of schematic in any A3 or A4 paper?
Do you mean input the components into the software?
No, not software. I mean, because some other students just now, I think you also see that they have drawn some kind of flow chart, right? Some flow chart with different components, or you have energy flows, you have like also the hydronic flows, like Li Ming, like Chen Xing, like different students. They have drawn this kind of schematics. Have you drawn this kind of schematics?
Yeah, but it's in my another laptop, so I didn't screenshot the whole diagram.
Okay, so you do have the interaction, right?
Yeah, but okay. I haven't run the simulation yet.
Okay. So remember that next time, please also show this kind of schematic to us. I need to see what kind of components are exactly existing in your system, and what are their interactions. What will be the energy flows? What will be the water flows? What will be the hydronic flows in the system? Where is the tank? Where is the heat pump? Where is the chiller? So I need to see them clearly, and then between different components, then you have the controls. So you need to show them clearly. Okay. Otherwise, it's difficult for me to check what is going on for your research work. And I can see that for your, what about simulation? How much have you implemented this kind of system into your simulation? Have you set up the models in your simulation? Input the equations. So what is the progress up until now for the simulation?
I'm fixing the SketchUp, but at the same time, I'm making like inputting all the components into it, and then try to put some data.
So you still haven't connected, right? So it's just some separate components. Okay. So try to speed up for the this simulation also. But of course, the first thing you need to check the demand, similar as what I presented in the visualizer. So you have to check the demand, what kind of building actually it is for your analysis. If you are working on a community, so how many buildings are there? So what are the demand? What will be the duration curves of the demand? You have to figure them out. And for you, this is a community, so it is not only one building. You have several buildings, so you have to figure out what will be the duration curves. So for example, you have two types of buildings: one office building, one residential building. Then probably, for example, you have two high-rise office building. You have three residential buildings. Then of course, for your research, I can see that okay. So if these two office buildings are exactly the same, then you multiply by 2. Okay, for your stage, for your level, I think that's acceptable. Then if we have residential building, whether that is a high-rise residential building or not, so then you can assume that there are 3 residential buildings. Then you multiply by 3. But again, multiply by 2 or by 3, it is just a rough method because in reality, in practice, we may not have the peaks at the same time. So if you multiply by 3, means that you assume these 3 buildings have exactly the same demand profiles, but that may not the case, or that may not be the practical situation in reality. Because in reality, someone is cooking, but the other guy in the other building may not be cooking at the same time. Someone is taking shower, the other guy maybe is just cooking. So they have different peaks actually at different moments. It may not happen that they have the same peak. But for your level, in order to get the demand, you can actually assume 2 residential or 3 residential or 2 office buildings. Then you have to analyze the demand. After analyzing the demand, then you can size the generation side, also size the storage. But for you, it's a thermal system. Then that's the heat pump. So what is the capacity of the heat pump? What is the capacity of the chiller? What's the size of the tank? So you have to size them. Then you can finish your job. So try to speed up because now it's just 1 month ahead before your midterm assessment for the midterm presentation. Okay, so now let's go on to the other master student. Shuping, are you there? Hello, Shuping.
Oh yes.
Okay. Please present your progress to us.
Can you see?
Yeah, very